Alrighty, my friends. Let's learn about differential equations. I do want to let you know that there are some strange noises coming from outside my house. I cannot do anything about that. They are currently cutting open my street. So we're going to solve some differential equations and do some initial value problems. What is a differential equation? Well, a differential equation, it has like this derivative thing in it. So a differential equation is something with a derivative in it. So maybe something like dy dx equals 7 would be a differential equation because we have a derivative sitting there. How do we solve them? What's an initial condition? So this is going to be very similar to what we've done before. We're going to do something that we'll call separation of variables often, and then we'll integrate and we'll find the antiderivative, and then the initial condition is like where it starts. So for example, if I do that one from the beginning, so if I have dy, maybe I just do this, 7 dx. And let's integrate both sides. Well, that's like 1 dy, so that will turn into y. And then 7 dx is 7x plus some sort of constant. And here's where the initial condition comes in. Suppose I tell you that this curve goes through the point 0, 4. So what does that mean c is? Well, you should be able to answer that. C has to be 4. Because if I plug in 0 for x, I better get 4. That's a basic, quick little intro. Let's see what we got. Solve the following differential equation by moving the y stuff to the left, so that's what we just did. So this is called separation of variables, where we separate the variables. We get the y's together and the x's together. So dy over y is k dx. If it makes you more comfortable to think of that left side as 1 over y dy, you may. Integrate both sides. 1 over y dy becomes, of course, the natural log. I'm going to put an absolute value in case we have to deal with any domain or range issues. Then we have k dx, so we have kx, because that was like 7x, and then plus some sort of constant. All right, let's see. We want to get y by itself. So let's go ahead, and a lot of y'all are going to say, let's e both sides. So we'll put e there and e there. And if we do that, and then we move this stuff, e to the natural log of y will just give us y, and then e to the kx plus c, I could rewrite that as e to the kx times e to the c. Well, isn't e to the c just a number? Because that's e, which is a number, to c, which is also a number. So that means I can rewrite this equation as y equals, I'll call it c1 e to the kx. If you're wondering why I put c1, it's because c1 could be different in value from c. In fact, it probably should be. Let's try another. Okay, so let's separate these. So I'm going to multiply by e to the y and multiply by dx, treating this like a fraction. It's not, but let's pretend it is. Don't worry, they're getting closer with their chopping of the street. Integrate both sides. Well, that's e to the stuff. So isn't that just e to the stuff? Because we're integrating with respect to y, we can just leave it there. 2x is going to be x squared plus some sort of constant. Let's go ahead and solve for y. So we'll take the natural log of both sides. Theoretically, we need an absolute value in there. So maybe I should have made those absolute value bars. So that's going to be e to the y. That will go there. So that would be y. Natural log of e is 1. Y is the natural log of x squared plus some sort of constant. Find the general solution and the particular solution. So first thing I'm going to do is get the y's together. So that's e to the y dy, because that's 1 over e to the y. And then get the x's together, 3x squared dx. Now let's go ahead and integrate both sides. So that's going to be e to the y, just like on the previous problem, and x cubed plus some sort of constant. Now, you have a choice. You could plug that point in now, or you could plug it in later. Since this says find the general solution, I'm going to go ahead and find the general solution first. So we'll take the natural log of both sides, just as I did before. That's the general solution, and now let's plug in. So we're going to plug in the point 0, 1. So 0 is the x value, and 1 is the y value. Well, the natural log of c is 1. That means c must be I was pausing for dramatic effect. C must be E. So what that means is that for this specific case, y equals the natural log of x cubed plus e. Now, if you're wondering what the heck is going on, we just found a function, this function here, whose derivative matches up with what we started with, and that goes through this specific point. If you don't believe me that we had that derivative, take the derivative and see what you get. Find the solution has y equals 0 when x equals 0. Okay, let's give this a shot. So I'm going to rewrite this as dy dx equals e to the 2x times e to the y. Let's go ahead and separate those variables. dy over e to the y, e to the 2x dx. Now I'm a little concerned about that left side, that someone's going to mess that up. So I'm going to write that as e to the negative y dy, e to the 2x dx. And let's go ahead and integrate both sides. So that's going to be e to the negative y with a negative. Don't believe me? Use u sub. And that's going to be 1/2 e to the 2x. Don't believe me? Use u sub. Plus c. Now I'm going to make a choice to plug in the point right now. So I'm going to plug in 0, 0. E to the 0, 1/2 e to the 0. Well, e to the 0 is 1. So that's essentially saying that negative 1 is equal to 1/2 plus c, which means that c is negative 3/2. Now, if you had done more work and plugged in later, you may have gotten a different c value, and that's okay. Because at the end, we will have something that looks the same. Let's move that stuff up, and let's plug back in. So we had negative e to the negative y, 1/2 e to the 2x. Oh, they stopped for a moment. That's great. Let's go ahead and multiply by a negative. Negative 1/2 e to the 2x plus 3/2. And then I'm going to go have over here on the right. I'm going to take the natural log of both sides. So negative y is the natural log of negative 1/2 e to the 2x plus 3/2. And then I'm going to multiply by a negative again. Negative natural log, negative 1/2 e to the 2x plus 3/2. And we did it. So if we took the derivative of that, we should get back to where we started.